am Pushpa. I am discussing about probability and queuing theory, the subject which is common to CSE and IT department. The objective of this paper PQT is to develop the analytical capability and to impart knowledge in statistical methods and the queuing theory and their applications in their engineering and technology, so that they can solve the real world problems easily. The first unit consists of random variables, which involves discrete and continuous random variable. We know that the discrete random variable takes countably infinite number of values, but the continuous random variable have uncountably infinite number of values. Along with that, those two, discrete and continuous random variable, we in detail will discuss about cumulative distribution function, which will cumulate all the probability values up to the particular point, and then along with those two random variable, discrete and continuous, in general we'll discuss about the moment generating function, which will generate all the moments about the origin, so that they are easy to calculate the central moments about the mean, with which we can find out the moment generating function also. And these are the very important formulas we discuss here in the first unit of the random variable, which will be with the expectation of x and the cumulative distribution function, mean and rth moment about the origin, variance, moments in general about the origin, and the moment generating function. And here we also discuss about the probability distributions with the discrete random variable and continuous random variable. The discrete random variable is with binomial distribution, which is with two parameters, n and p, where n denotes the number of trials and p is the probability of getting success. And the second distribution with the discrete random variable we discuss here is Poisson distribution. It involves a parameter lambda, which you can get from the product of n and p, like in binomial distribution. And the third distribution is geometric distribution, which is with the parameter p. Actually, binomial distribution, when n and p are known, the number of trials and the probability of getting success is known, we will discuss here along with the binomial distribution. When n is more, almost tends to infinity, and p is almost small, which is impossible, negligible value, in that case, for very rare events especially, we will discuss with Poisson distribution. And geometric distribution is like a probability of getting first time success. And in the continuous random variable, the following distributions are here. Uniform distribution, it's with the two parameters a and b, the lower limit and the upper limit should be given. And the exponential distribution should be with the parameter lambda. And gamma distribution is alpha and beta. Along with these three, we'll discuss for the continuous random variable the normal distribution also. And these are the PDF, the probability density functions, moment generating function, mean, variance of each of the distribution is given here. And in the second unit, for the PQT subject, the discrete for the two-dimensional random variable case, we discuss here discrete joint probability distribution, which is our JPMF, and continuous joint probability distribution will define as JPDF, joint probability density function. And for these two cases, discrete or continuous, will define the marginal probability distribution, which will consider only the function of x, a function of y. They are called marginal probability distribution of x, marginal probability distribution of y. And then conditional probability distribution we have here. We follow all these notation. This is the case with discrete, and this is the case with the continuous case. For the continuous case, it is defined as conditional density function of x given y, conditional density function of y given x. And then for the discrete and continuous together, we will discuss here expectation of a random variable, which is actually moments about the origin, and also like our one-dimensional random variable, cumulative distribution function, which will cumulate the probability values of x and y up to a particular point x and y. And here the correlation and regression is also discussed. Correlation is actually defines a relation between how much they are related, x and y, the independent variables are related to each other. It defines the strength of the relationship between x and y. And regression, using this we will define a relation between x and y either as a linear equation or as a curve. Regression line x on y is, the equation is given here, where bxy is our regression coefficient for the line, and regression line y on x is given here. Byx is the regression coefficient y on x. The product of these two regression coefficient taken within the square root gives the correlation coefficient. So you can consider rho as plus or minus square root of bxy and byx. The plus or minus, which depends on the nature of the regression coefficient. If they both are positive, the regression correlation coefficient should be taken as positive. If both the regression coefficients are negative, correlation coefficient should be taken with the minus sign. And then the last topic in the second unit is the transformation of two-dimensional random variable, which we discuss here for the one-dimensional case and two-dimensional case. Given a PDF of x and along with the transformation, to get the PDF of the new random variable y, we have the formula f of y equal to f of x into modulus of dx by dy, which you can written as f of x divided by modulus of dy by dx. And the transformation of two-dimensional random variable, here we have x and y along with the joint PDF, and the transformation u and v are given in terms of x and y. To get the joint PDF of u and v, we have the relation f of u comma v as the old PDF, joint PDF f of x comma y multiplied by the Jacobian value.